Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problems of this weekly contest 3 to 4, and the problem that we are going to talk about is smallest value after replacing with sum of prime factors. Okay, so yeah, the problem is very much simple. The only thing that you need to calculate is the how you are going to calculate efficiently the prime factors of a given number. So let's try to understand this problem. We are given a positive integer n, and continuously you need to replace n with the sum of its prime factors. Okay. Note that if a prime factor divides n multiple times, it should be included in the sum as many times as it divides n. And you need to return the smallest value n will take on. Okay. So let's understand this with example. Suppose n is 15. So what are the prime factors of this 15? It's 3 and 5. Okay. So what you need to do is you need to replace n with the sum of its prime factors, which is 3 plus 5. So it is going to be 8. Okay. Okay, yeah, we are done. So now n is 8. Now you need to replace n, like you need to find the prime factors of n, which is going to be 2 power 3, and the prime factor is only 2. Okay, so you need to replace n with the sum of its prime factors. Okay, so what are the prime factors of this one, which is 2 plus 2 plus 2. Okay, note that you need to count, you need to also consider the duplicate prime factors. Like suppose here it is going to be 3 square and 5 power 3, then you need to consider 3 plus 3, and you need to also consider 5 plus 5 plus 5. Okay, you need to consider all these. Okay, here we are having 2 power 3, you need to consider 2 plus 2 plus 2, which is going to be 6. Okay, now you can see here, if you consider 8, it would be 2 cube, so replace n with 6. Now we have again 6, n as 6. Now you need to replace n with its prime factors, which is going to be 2 and 3. Okay, so what you're going to do, you're going to write down n as 2 plus 3, which is going to be 5. Now when you try to replace n equal to 5 with its prime factors, you can see you will get only 5. So 5 will remain as it is. Okay, so when you get a same n, then you are going to stop it. So final value where we are going to stop is equal to n equal to 5. So let's try to take another example. Let's say our n is 6, or not calling it, let's say our n is 9. Okay, so what you're going to do is you're going to check it out its prime factors, which is 3 square, so which is nothing but 3 into 3. So you need to replace n with 3 plus 3, so which is going to be 6. Now again n is 6, so you need to find out the prime factors, which is going to be 2 into 3. So you need to replace n with 2 plus 3, which is going to be 5. Now n is 5. When you need to find out the prime factors of n equal to 5, you will get only 5. Okay, so 5 is going to be replaced again, so you will get 5 and 5 again, so you need to stop it. So our final value of n is going to be 5. Okay, so you need to calculate that prime factor efficiently. For that, you need to use some efficient method. You can also use the brute force method, but I've used the smallest prime factor using sieve method. If you don't know this method, you can refer this article, least prime factor using sieve. Okay, so yeah, so you will get this article, prime factorization using a sieve, that would compute in O of log n. Okay, so this entire part will just store the smallest prime factor for each number. So if SPF of a certain number, let's say SPF of 8 will be a certain number, let's call it as x, x will be 2, SPF of 8 will be 2, because smallest prime factor of 8 is always 2. So that's what we are is trying to store over here. For each number in the range from 1 to n, we are storing the smallest prime factor for each number. So this is the code for that part. Okay, so so what we are going to do is we are just iterating this one till we get the same number. So if new n is equal to n, we will just break, otherwise we will just swap new n and we'll perform the same operations. Okay, so let's initialize our new number with 0 and number equal to n. So while number is greater than 1, so we'll just find out the smallest prime factor of the current number, and we'll just try to reduce the current number till it is being divisible by x. Okay, and also we need to add up the digits, like add up the prime factors that we are going to have. Okay, so if new n is not equal to n, we'll just swap it, otherwise we'll just break it and we are done. And finally we'll return the n, which will be our answer. So yeah, the problem is really very much simple. All you need to do is to pre-compute the prime factors efficiently. So if you have any doubts, you can reach out to me through the comment section of the video. And thank you for watching this video. Do not forget to subscribe.